These are the electrical schematics for the 2024 robot. So this is what I was intending to do, and I'm sure it's challenging to see, but long story short, pretty much all of these motors have encoders connected to my microcontroller. And if someone is not familiar with encoders, what they do is they allow you to calculate the position of the motors. So the initial plan was to have the position of the motors be tightly controlled by the microcontroller, allowing me to move it in a very precise fashion. But as I began implementing these, there was a number of implementation issues. Um, One being that I wasn't able to effectively use interrupts to kind of have a well coordinated control. So they just simply weren't really working that well. So I decided to kind of take a step back from using encoders and switch to a much more simple electrical system. So this is what I actually ended up implementing. It's more of an electromechanical system than a mechatronic system, as we can see here from these push buttons. A lot of these motors are directly controlled by the push buttons. And in order to change the direction of the motors, I manually had to use jumper cables to flip the cathode and anode connection for these motors. So it was very unwieldy to use, but it was able to produce effective results. My robot was really functioning much more like a machine. And even in the actual implementation, I still did use a microcontroller connected to a motor driver to control the scoop motor, because the scoop did require much more precise movements. But instead of using encoders, I just had a time-based system, kind of finding that 0.5 seconds of runtime was perfect for the scoop to toggle between its two different states. So yeah, that was kind of that's the electrical implementation that I used, and in the next clip I'll show some actual images of this system. I also implemented in the actual design a little pull down resistor button setup, which was the button that toggled the scoop. So here's the actual system. It's not the full thing. You can't really see the motors in it. You can't see the battery, but you can tell that it was a mess. Cables were tangled up, buttons everywhere, breadboards. Was really messy. And as I mentioned, I had to use alligator clips while I was operating the device to switch whether it was moving up or down, and even control which side it was moving. So it was very unwieldy, and it really took the creator of this robot to operate. So yeah, I've discussed this a couple times, but a primary goal for next year will be streamlining this and having it fully autonomous. Whether I make it fully autonomous with encoders, like my initial plan was, or whether I use some sort of camera that's equipped with some sort of AI classification or some other system where it can detect when it's properly positioned. That's up for me to figure out. But yeah, that's kind of the rundown of the electrical system that was used. Thanks.